Welcome to the Isaac Flores Software's HydroCal program, an engineering tool to better evaluate risk. This program is based upon this manual slide rule type hydraulic calculator to calculate friction loss from a test location to the base of a sprinkler riser, considering different type of pipe sizes, pipe age, and pipe schedules, in addition to considering water supply test information. It calculates the friction loss and it plot test results showing balancing water supply against sprinkler demand and friction loss. Let's begin. There are several forms that the program has, and the first form is the data form. I'm going to demonstrate the form. This is the data form. We enter customer information, water supply data available from the water department, sprinkler demand for the facility, and if you have a warehouse, it also enters in rack sprinkler information, and the program will balance demand against supply. In addition, we have a pipe and fitting table that you can select. You can enter the pipe size, different fittings, and you could consider elevation, starting elevation at the fire hydrant and end elevation at the sprinkler riser. You could also, if you do not have the water flow test from the water department, you could conduct your own water flow testing. You will enter the static pressure, residual pressure. You could flow using plate pipe nozzles, fire hydrants, or hose monsters. You just select the device you're flowing, enter the period of pressure, and the program will calculate the flow. The program will then, you could generate a report by clicking generate a report, and you could plot friction loss against the sprinkler demand or the water supply. And the program will generate this report. We'll fill it up for you. There's a graph generated. Okay, so let's begin. Let's go back and start entering data. We click data form. In this particular location, I'm not going to enter all location there. I'm just going to type ABC company. Every time you click a button, this little window opens where you go enter the data. We enter ABC company. Let's enter water flow test information from the city. Our static pressure is 120 psi. Our residual pressure is 100. Our flow is 2,000 gallons per minute. Our sprinkler demand is 1,400 gallons per minute. Our demand pressure is 80 psi. Our sprinkler design density is 0.30 GPM. Per square foot. We're going to have a hose demand that we give to the fire department. That's 500 gallons per minute. In this particular facility, we have a warehouse, and we got an in-rack sprinkler system, or several sprinkler systems. But we enter information for the largest one. The largest one has a demand of 450 gallons at 45 psi. So we entered all information that was needed except the address and building name and so forth. But that's not needed for demo purpose. Let's click, let's continue and enter pipe data. Click next, and the form for pipes and fittings opens up. We have a 10-inch pipe from the test location, fire hydrant to the base of the sprinkler system. So select 10-inch pipe. We select the pipe schedule, duct iron. We select the type of pipe, mainly the age, and we have a 10-year-old cast iron pipe. Our pipe length is 500 feet, or let's say 500 feet from the test location to the base of the riser. Fittings. We have several fittings, and this fitting was pre-selected. Let's balance them out to show no fittings. We select the fitting and we select the quantity. So let's zero out everything. Now let's begin. We have standard T is one standard T, one flange elbow, degree flange elbow. Let's say we got two of those elbows. And we have one gate valve. So those are the fittings we have in this particular location. We click next. And we need to select the elevation. If you do not know, it's better to leave it blank. But you could get elevation from Google Earth that shows the elevation at different points. And if you have Google Earth, you could determine the elevation at the test location and at the base of the sprinkler riser. So the information we got is that the starting elevation is 100 feet above sea level. And the elevation on the riser is 105 feet. So end elevation is 105. Let's cancel all the information all the information that we enter has been put into the program except friction loss. Friction loss will be entered when we click pipe 1. We only got one pipe, a 10-inch pipe, so let's click pipe 1, and the program calculated the friction loss of 5.5 psi considering elevation and friction loss on the 10-inch pipe. And this is the friction loss is calculated based upon the sprinkler demand of 1400 GPM. You could generate a report considering two flows. We could consider friction loss based upon sprinkler demand, or we could consider friction loss based upon water flow tests. Let's look at friction loss based upon water flow tests. And this is the data we enter. ABC company. We do not enter the address, we do not enter building number, and we do not enter the date or system number, and we do not enter conducted by. Our water flow testing starting elevation 100 psi. Our water supply static pressure is 120 psi. Our residual pressure is 100 psi. Our flow from the water company is 2000 GPM, and our end elevation is 105. We use the water flow test data from the water department, so we did not flow any devices, so we do not enter orifice coefficient, orifice nozzle diameter, or pedal pressure. So that's Our sprinkler demand is 1400 GPM at 80 PSI. Our density is 0.30 GPM per square foot. Our hose demand is 500 GPM. Our in-rack sprinkler demand is 450 at 45 PSI. And when we balance the sprinkler demand against the ceiling water pressure, our in-rack sprinkler demand increased to 600 GPM at 80 PSI. Our total ceiling sprinkler demand is now 2,000. 600 gallons plus 1,400 gallons is 2,000 gallons per minute. Our friction loss is 9 PSI. This is our friction loss data that was transferred to the report. And this is the graph that was generated. We have the water supply test of 2,000 GPM at 100 PSI with a static pressure 120. So this is the water supply line. For this water supply line, we subtract a friction loss of 9 PSI at 2,000 GPM. So this is the water supply now available at the site. And from this water supply line, we give 500 gallons to the fire department. We take this point, 3,000, and subtract 500. So at 2,500, we draw a line. And the same will do the same thing over here at 1,000 GPM and 77 PSI. We subtract 500 GPM. So that gives us 500 GPM at 77, and we connect the two lines. And this represents the water supply available after the fire department arrives. This is a sprinkler, in-rack sprinkler demand, 450 gallons per minute at 45 PSI. This is our ceiling sprinkler demand, 1,400 GPM at 80, and we increase our in-rack sprinkler pressure of 45 to 80 PSI to balance it to our flow for the in-rack sprinkler demand increases to 600 gallons per minute. Then we add 600 gallons per minute to our ceiling sprinkler demand of 1,400 gallons, and our total demand is 2,000 gallons per minute at 80 PSI. And it shows that the water supply is excellent. It's adequate enough to meet in-rack sprinklers, ceiling sprinklers, and total in-rack sprinklers and in-rack sprinklers and ceiling sprinklers, as well as giving the fire department 500 gallons per minute. So this proved that supply is adequate for this facility. We could go back and that's it. This demonstrates the Flores software hydraulic calculator program. Thank you for viewing this demo.